Yo, what's up, my physics peeps? So, we're back with another video. This is problem number 28 from a AP Physics C Mechanics multiple choice test. We're going to go through this problem today. So, we've got a diagram here with blocks A, B, and C aligned along a straight line on a horizontal frictionless surface. The masses of the blocks are m, 2m, and 3m respectively. Block A is initially moving to the right, shown here with the initial velocity. I'll make that a naught on the bottom, v naught. So it's initially moving to the right at speed v naught. Blocks B and C are initially at rest here. Block A collides and sticks to block B. The two blocks then collide and stick to block C. What is the speed of block C after the collision? Alright, you know as soon as you see the word collision that we're going to be talking about momentum here. We're talking about one block moving, two blocks still, and then at the end all of the blocks are going to have stuck together and be moving. So again, this is what you call an inelastic collision. Actually a perfectly inelastic collision because the blocks are sticking together. That means kinetic energy will not be conserved, but momentum will, because this is a closed system with the three blocks. There's no external forces being added. So let's hop right in with our momentum equation. So we know that momentum is equal to mv, mass times velocity. So we're going to set up initial momentum on the left-hand side of the equation is going to be equal to the momentum at the end of the equation on the right. So here we've got mv. That's going to be our starting starting momentum. I'll just make this initial. And this really only pertains to block A, because the other blocks, I could write them out here, but since they have zero velocity, it's just going to cancel out. I can say mv initial for block A plus mv for block B plus mv for block C, but those are all zero. So we're just going to leave that out as long as you understand that we could write that in. And then at the end, what we're going to have is all three blocks sticking together as one sort of one like object that's moving together. They're sticking because these are inelastic collisions. So the way we're going to write that is we're going to have the mass of block A, which is just m. What's the mass of block B? It is 2m. The mass of block C, 3m, all times our final velocity. And going from this problem, or going from this setup, we can start to solve. So what we're looking for is the speed of block C after the collisions. But all three blocks at the end are going to have the same speed because it's one system. Block A at the end will be going as quickly as block B, as fast as block C. So what we're solving for here is velocity final. So let's add these m's together. We've got m times our v initial, I don't know why I wrote initial, v naught, let's just keep it simple, is equal to m plus 2m plus 3m, that's 6m v final. So now we're solving for v final, so let's divide by 6m. I'm just going to rewrite this over here. So m b naught over 6m is equal to velocity final. Our m's cancel out. And what are we left with? We're left with v naught over 6 is equal to velocity final. Using conservation of momentum, because these collisions are inelastic, there's no external forces, we can apply this model to the problem. So let's check our answers. Looks like it's going to be B, and yes, that is the right answer. None of those. Alright, thanks for watching. Let me know what you think. Questions about momentum, anything here, comments, concerns, etc. drop them in the comments below. Thanks for watching, and check back for problem number 29.